Good morning, students. Students, today we will be revising some important questions which are done in second term of class 8th in the subject of physics. So our first question is, which mirror will you prefer to use as a rear view mirror in a car? That is, will you prefer a plane mirror or convex mirror? You have to give one reason for your answer also. So children, actually we can use both the mirrors, plane mirror as well as convex mirror, as a rear view mirror. But we use a convex mirror. Why so? Let us understand the answer now. So children, a convex mirror diverges the incident light. A convex mirror diverges the incident light beam and always forms a virtual image which is diminished in size and is formed behind the mirror between its pole and focus. So children, we are using convex mirror which diverges the incident light beam and it always forms a virtual image which is diminished in size and is formed behind the mirror between its pole and focus. And children, a convex mirror will provide a much wider field view. So this is our basic reason that a convex mirror provides a wider field view as compared to plane mirror of same size. Now okay, we can understand this by using the diagram also. You can see the two diagrams drawn. In one case, I am using a plane mirror which is silvered from its backward side. It is silvered from its back side. And children, suppose a driver is sitting in front of a plane mirror, and the light which is incident on the plane mirror, first light ray which is incident, will get reflected and the light will be seen by the driver. Similarly, there is second incident light on the other end of the plane mirror, and this incident light after striking will be reflected towards the driver. So if we draw a normal in between these, angle between incident ray and the normal is angle of incidence, while angle between reflected ray and normal is angle of reflection. Kindly note the arrows here. In incident ray, the arrows are marked towards the plane mirror, while the reflected ray, the arrow is marked towards the driver. Now, if you draw the incident light and produce it backward, there is a point where the two incident rays, these rays will strike and an image is formed behind the plane mirror. Now, if you just see the field view, how much area, how much region is plane mirror covering? That is its field of view. So this arrows shows you the field view of plane mirror. Now, if we use a convex mirror of same size, there is another diagram in which a convex mirror is used, and this convex mirror is of same size as that of plane mirror. So again you will do the same process. You draw an incident ray falling at one side, getting reflected towards the driver. Then incident ray from the other side getting reflected towards the driver. And then you mark it, produce it behind such that an image is formed. And children, in case of plane mirror, your normal was a straight line because the surface was completely vertical. But in this case, we are having your normal will be drawn a little tilted because the surface is curved. So, and children, remember the normal and the rays which have to be made behind the mirror has to be shown dotted. Now children, if you see the field of view, see what is field of view? It is the distance between the first incident and the last incident ray. So if you compare the field of view of both plane and convex mirror, you can easily observe that field of view of convex mirror is more than field of view of plane mirror. So children, when you are doing this question, whenever you are answering this question, make sure you draw the diagram also in this way and label all the angles and write down normal, and then you explain by giving the reason here. So coming to the next question, when an object is placed at a distance of 40 centimeter from a concave mirror, first of all, write down what is given. When an object is placed at a distance of 40 centimeter from a concave mirror, so U is minus 40 centimeter. The size of the image is 1/4 of that of object. So height of image is 1/4 of the object. So I can say height of image is 1/4 of height of object. Calculate the distance of image from the mirror and what will be the focal length. Now children, in case of a concave mirror, whenever you are forming a diminished image, whenever we are forming a diminished image, your image is real and inverted. So what do we mean by here? We have to first of all find magnification, which is HI by HO, and HI can be written as 1/4 of height of object. So M comes out to be 1/4. But since the image formed is real and inverted, I'll write down it as M minus 1/4. And then children, use the formula V by U is equal to minus 1/4, and V will be minus 1/4 into what is U? U will be taken here and U will come out to be, it was minus 40. So you find the value of V from here. Actually the magnification is minus V by U. So put it minus V by U, cancel this minus with minus. This minus is not here. But U was minus, so your V comes out to be minus 10 centimeter. Now use the formula of mirror formula and then you can find the value of focal length also. Try this question now further on your own. So the next question, question number 3 is, observe the figure shown below and then name the poles A and B and also give the reason for your answer. So you will be provided with a diagram in which you are having a bar magnet and the two ends of the bar magnet is shown as A and B. And children, magnetic field lines. Some of the magnetic field lines are going inward, and at some place the magnetic field lines are coming outward. Now you can observe the diagram clearly. So we can say that A is South Pole and B is North Pole. Why so? The reason is that outside the magnet, magnetic field lines are directed from north to south pole. We have done this thing, that outside the bar magnet, magnetic field lines are going from north towards south. So they are coming out of north and entering in south. So see, from B the magnetic field lines are coming outward. So B should be north pole. And at point A, all the magnetic field lines are coming inward. So A is your south pole. So the reason is outside the magnet, magnetic field lines are directed from north pole towards the south pole of the bar magnet. And in this given diagram, magnetic field lines are entering at point A. Thus, A will act as south pole. Then children, kindly learn all the SI unit of various terms which we have done in this term. Now the SI unit of action, we have done action and reaction in Newton's third law. So give the SI unit of action force, electric current, work, resistance, potential difference, and charge. Now children, in case of action force, now whether it is an action force or reaction force, whether it is action or reaction, it is just a kind of force only. So children, whatever kind of force we have, we will write the units in terms of force only. So the SI unit of force is Newton. Thus, the SI unit of action force is also Newton. Even reaction will have the SI unit as Newton. Electric current is measured in ampere. Then comes work. The SI unit of work is joules. Resistance is measured in ohm. Potential difference is measured in volts, and charge is measured in coulombs. So you have to learn all the SI units, since it is very, very important to know how the quantity is measured and in which term. Now children, the question comes, differentiate between a conductor and an insulator. So whenever you are writing differences, you have to write down in column method. You will write down first term on one side and other term on the other side and draw a line between it. So when you are making differences, make sure that you are writing down it in tabular form. So put a line in between and then write down in form of comparison. So the first thing is the substances which allow electric current to flow through them easily are called conductors. Children, don't write down the substances which allow heat to pass, since we are doing the chapter of electric current. So you have to write down the definition in terms of current, electricity. So the substances which allow electric current to flow through them easily are called conductors. and the substances which do not allow electric current to flow through them are called insulators. See, we have compared the two things in similar points. That is, the substances which allow electric current to pass through them are known as conductors, and the substances which do not allow electric current to flow through them are known as insulators. Now, the next point is very important. Conductors offer a very small resistance. What is resistance? Resistance is opposition provided to the flow of current. Now, conductors offers very small resistance to the flow of current. Why? Because they have a large number of free electrons. So conductors offer a very small resistance to the flow of current because they have a large number of free electrons. While insulators, they have almost no free electrons and thus they offer a very high resistance to the flow of electric current. Now the third point can be the examples. So children, example of conductors can be all the metals like silver, copper, brass, etc. Human body is also a conductor, while impure water, just learn, I am talking about impure water. Don't write down just water. You have to write down impure water. Impure water is conductor. And examples for insulators are cotton, rubber, wood, glass, pure water. Children, impure water was conductor, but pure water is an insulator. Leather is also insulator. So your third point can be the differences, the examples, and those examples have to be written in a precise manner. Like if you write down water, then you don't get a mark since impure water is conductor but pure water was insulator. Now the next question is, what is responsible for the flow of current through a metallic conductor and an electrolyte? So this means that in a metallic conductor, what causes flow of current? And in an electrolyte, that is a liquid solution, what causes the flow of current in an electrolyte? So let us learn its answer. In a metallic conductor, free electrons are responsible for the flow of electric current. Free electrons are responsible. While in an electrolyte, you don't write down electrons. Here we have positive and negative ions. So both positive and negative ions are responsible for the flow of electric current. Next question is a numerical here. A current of 3 ampere flows through a conductor for a second. So current is 3 ampere and time is through a second means 1 second. What amount of charge passes through the conductor? So use the formula I is equal to Q by T and you have to find the value of charge. That will be current multiplied by time. So 3 multiplied by 1, 3, and the unit should be written as coulombs. 3 coulomb. Next question is state and define the SI unit of potential difference. So you don't have to just write down the unit. You have to define it also. So first of all, you write down that SI unit of potential difference is volt. And then according to the formula, volt potential is equal to work upon charge. I can say that 1 volt is equal to work means 1 joule divided by 1 coulomb. So how to define potential difference? Potential difference between 2 points is said to be 1 volt if work done in transferring 1 coulomb of charge from one point to the other point is 1 joule. So, children, potential difference between 2 points is said to be 1 volt if work done in transferring 1 coulomb of charge from one point to another is 1 joule. Now, children, in question number 9, I have given you 6 differences. All these differences have been covered in this term. You have to write down at least three differences in each category, and then you learn those differences. So you write down each differences in a tabular form, and as we did the differences between conductor and insulator, in the same way you write down at least 3 differences between each term in your physics notebook, and then learn all those differences. Thank you, students.